Before I pass to our BPS colleagues, I would like to invite if any one of you have any question, or maybe after this session yesterday, you did some practices and you find any issue, please. Time is yours. Can turn on your camera. We welcome any comment or any question from participants, please. No question from Myanmar or from Laos or from Vietnam. Do you have any question? Any question related to the sharing session yesterday, whether on the comment or any other related question? Thank you, Myanmar, and I'm glad to hear that you can follow the yesterday lectures. So I assume there is no question from Myanmar, or everything is clear. How about others? Do you have any issue or challenges? I see no raise hand and no other reaction from other countries. Anyone? Okay, since everyone is clear, now time for quizzes. Okay. There's a question from LSB. Maybe I would like to check our colleagues from BPS, Mbak Erna and Mbak Dewi. Miss Erna and Miss Dewi, if you can see in the chat box, there is a request from LSB to briefly introduce R.
Yeah, all right. Thank you, Mbak Warda, and good morning, everyone. I hope that today we're gonna have the continued session from yesterday's session. And regarding the question from Mr. or Miss Somsame, can you brief on introduction in R? I thought,
Maybe just briefly summarize from the yesterday session, Mbak Erna.
oh, I see. So yesterday we had Mbak Dewi in presenting the introduction in R. First of all, you already know that R is an open source application. It's free, and you don't have license to conduct analysis with R, so it's a good thing. And then you can freely download it, and I think that the link is available on the yesterday's material. You can go back to the material and find the link. And then basically we concentrate this material in how to do data processing with R. So yesterday you already know that R is run based on packages. So you know that there is a packages named tidy first. It's basically for data science, in which you can like manipulate or create a new variable, or you can like make a aggregation, or you can like or or just in short, it's for a data science to manipulate the variable. I thought that was yesterday material, and today basically we do more practical. We're gonna implement what you've learned yesterday. So I'm gonna give you some data. I believe that Mbak Hani already distribute the folder in which you can find the data, and then PowerPoint that I will present today. So hopefully you already download it and prepare for it. So yeah, we're gonna going through one by one the slide in our script. So hopefully you can follow it. And probably, should I go back to Mbak Warda or start the session?
You may continue, Mbak Ena,
Okay.
since you will be the speaker for today's session, right? But before that, maybe I will just reiterate again that after the exercise today, we will do some brief discussion on the data preparation with all participants. So hopefully each country already prepared their data and then can show to us what indicators they selected, whether it's poverty related one or the employment related one, and then what variable they already prepared. So our colleagues from BPS and including from Thailand and Philippines can provide some inputs on the selection of indicators on the data preparation and as the whole. I think that's all, Mbak Ena. Over to you.
Okay. Thank you, Mbak Warda. Sorry, one more thing. Can I propose like a 5 to 10 minute breaks in the middle? Yeah. Okay.
Sure, sure, sure.
Okay. Thank you.
If you have quizzes, we can do also quizzes.
All right. So everyone, I already sent the updated material of PowerPoint and the RMD file. Basically, it's quite similar from yesterday. Yesterday that distributed by Mbak Hani, but this one is more updated. Like I did like some small changes on it, so you can like download it, and then let me share my presentation. All right. Uh, does it appear on the screen?
Yeah, Mbak Ena,
Yeah.
we can
Okay.
see it.
Right. Okay, as I mentioned before, that today we're gonna have pre-processing data of a certain census called PODES. PODES mean village potential. So we're gonna have get to know more about PODES later on. I'm gonna explain it. So uh, I believe that everyone already download the PODES data that I give you. It's on DBF file. So PODES is a census conducted by BPS-Statistics Indonesia. PODES is a brief from a potential village. So the units of observation of this census is village, uh, and it collects various information regarding the characteristic of social economy of all villages in Indonesia. So there were around 84,000 villages that become the unit observation of this census. So it's quite big. And then the information are that are included in this census involve like the information on demographics such as the in which the village is located, for example, whether the village is located in the plateau or in the lowland or a shore area or something like that. And also include information about economy. For example, in which sector the majority of population in a certain village work, and and also probably information about the number of the markets, the banks, or the market, the banks, or the stores, or yeah, in a village. And then it also includes like information about social services, like the number of schools, starting from elementary, junior and senior schools in a certain village. And also it also include information about infrastructure such as road, or probably road that can be accessed, whether a village have roads that can be accessed in all seasons route. And then also the number of health facilities, such as the number of hospitals, or the number of healthcare, healthcares like doctors, nurse, or midwife, or something like that. And also, it contains a lot of information about social economy, or in all the characteristic about a certain village. So just give you an idea about the administrative areas in Indonesia. So Indonesia contain like 34 provinces, and they are broke down into districts, and then we have sub-districts at lower level, and the lowest level of administrative areas in Indonesia is villages. So the unit of observation of PODES are the lowest administrative areas in Indonesia, which are villages. Why this census PODES can be offer potential solution in conducting small area estimation, because we in Indonesia have the two main regular censuses. Sorry, this is not a regular census, a regular survey, which are Susenas, National Socioeconomic Survey, and Sakernas, National Labor Survey. The two surveys are called the mother of survey, because many indicators, social and economic indicators, are generated from those two surveys, or call it like the poverty level, or the number of average school of children, or the morbidity indicator, are coming from Susenas, where meanwhile the indicator of labor, such as the unemployment rate, the NEET rate, are coming from Sakernas. So the two survey are the mother of survey of in Indonesia. However, these two surveys are designed to provide indicators or statistics only until district level. So if we are trying to calculate or to provide indicator at the lower administrative area than district level, we're going to come to the issue of accuracy, which is a big relative standard error. We use relative standard error to measure the accuracy. So we cannot provide the statistics at the sub-districts area. For example, poverty in Indonesia is presented up until this district level. But however, as we know that the need of more disaggregated or granular statistics such as poverty and unemployment rate rises to support planning and development programs. Particularly in the SDGs framework, we hope to achieve uh, the principle of no one left behind. So it's very important to provide the indicator, the social economic indicator, until lower administrative area. So hence in this case, since the PODES is a census, it covers all areas in Indonesia. So the PODES offer potential solution uh, to help us develop small area estimation to provide more granular or more disaggregated statistics. So going deep into PODES, so this is basically just the questionnaire of PODES. Pardon me, I don't have the PODES questionnaire in English version, but I will try to explain it to you. So basically, this is just the questionnaire that we use to conduct PODES. So here we have this one is we call it like a chapter or block. Block one, it includes the information about the location of a certain village. So PODES has around 19 chapter or 19 blocks. It's categorized based on the information, probably the health information, the economy information, and the social information here, because it's related to how the data or the file presented in the DBF file, or later on we will open the PODES in R. So here I just want to give you a little idea how to the raw data presented in the file that I give you. For example, here we have 101. It's information about province. And in the file, you will find R101. It means that the column R01, it covers information about province. Same as like 102, 103, and go on, and etc. So here we have a 101 R101 province, 102 R102 the information regarding the districts, or 103 regarding the information of a sub-district, R102, and 104 regarding information regarding villages. So I give you another example of another chapter in PODES questionnaire. Here we have chapter 6. It collects information about disaster and the mitigation. So here contains a lot of information. And for example, here the information here regarding this column, it will be presented in the file using the code R601, because it's coming from A. So this one is A. And then K refers to column. K refers to column because it's coming from the second column. It says column 2. So if you want to get the information in this column, so you have to find R601AK2 in the DBF file, or in the file that we will work on it. And then this one is also the same because it's coming from column 6. So you have to find the code R601A column 6. So this is also the case from this one. It's gonna be R601C column 2. Okay. All right. So this is just the appearance of the data file of PODES that I already sent you. This is what I already mentioned. This column refers to different informations of the questionnaire. For example, first column, it contains information of the provincial code because it's coming from R101. If we can go back, sorry. If we can go back here, so you can see that R101 contains information of provincial code. So here, R01, if you wanna get the information about the provincial code, you have to look at the column R101, and etc. This one is also the code. This one refers to the questionnaire. All right. So here, just want to give you a little recap from yesterday's session. So basically, today we're gonna use a lot about tidying the data. So as you know that I'm pretty sure this is also the case in the data of your country. So before we conduct modeling or we build the modeling, I'm pretty sure that we have to do some the data pre-processing because often the data needs to be cleaned and as it's available not in our desired format. So this package named tidy first is used for the data cleaning. For example, selecting variable or filtering observation of you wanna creating new variables or joining the data set preparing auxiliary variables. So today we're gonna do all this tidy data or tidying the data in our exercise today. Sorry. Okay, I think that this is something that Mbak Dewi already mentioned yesterday, that if you want to select or choose variable or choose certain column, use select function. But if you want to choose a certain rows, you have to use function filter. And then Mbak Dewi yesterday you mentioned about the pipe function. It means next. And then, all right. And then in this case, we have to filter the observation. For example, the data, the PODES data that I already sent you, it's include all the villages in Indonesia. But today, we're gonna do pre-processing data only on Central Java province, which the code for R101 code is 33. So we are gonna use filter function in this case. First thing first, in using R and conduct pre-processing data, we have to read the data. So the good thing about R is also it can read the data in various types of file. R is capable of reading data from many formats such as Excel, either in CSV, XLS, or TXT format. And also, it can also read the files that are created in other statistical packages such as Stata, SPSS, SAS, or others. Since I believe that several of you are quite or are use data, so you can read your data that are stored in data into R. For example, here, if you have a CSV file, you can use the function read CSV. If you have Excel file, you can read the file in using read Excel function. But here, if you want to read the CSV file, you don't need to load certain package because it's already default in R. But if you want to load the Excel file, you have to have packages named read XL. Read XL. So if you don't have it in your R, you have to install it and then load the library read XL before you can open your Excel files. Okay. Meanwhile, if your data are stored in other statistical packages, you have to install a package named foreign. And then you have to load it, the library foreign. Because the PODES data that we will use today is stored in DBF file. So first of all, I would like to ask you to make sure that on your R, you already have packages named foreign, and please install and load the packages foreign before we start to the next activity. Okay. So everyone, I already sent you all the file. So move to R. Move to R. I have everyone open the R application on your own PC on your laptop. I already give you the R project. Um, sorry. Okay. Since I already sent the R project, you just simply click the R project called preprocessing R here. Just click. Wait. Okay. Is everyone already open the R and then R project that I already give you? And then please open the RMD file that I just sent you this morning before the session. It calls pre-processing village potential.
May we check whether participant can access the file and you can successfully open it in our studio? Okay, we have reaction from Myanmar. Thank you. They already follow. What about others? Okay, Lao already also follow. Can we check with other countries, participants from other countries as well, please? And can you follow the steps or do you need more time? Appreciate if you can have if you can give us indication. Maybe you can write in the chat box or you can provide any reaction. Okay, good. Thank you, Myanmar. So hopefully other participant, even though you don't give any reaction, you can also follow the steps. Over to you again, Mbak Erna.
Okay, thank you, Mbak Wardah. So everyone, we are not in a hurry today. I will make sure everyone will follow step by step. So if you still have an issue to follow what I presented, please don't be hesitate to let me know. So make sure that everyone follows step by step. So already everyone already download the open the R. Coming from reading the data, as I told you that the PODES data is stored in DBF file. Here you can see in the R project, there is two DBF files here. All right. So the first file, they are all about the PODES. The difference is the first file contains the PODES data from chapter 1 until chapter 7, while the second files contain PODES from chapter 8 until chapter 13. So basically, they are separated into two files. What you're gonna do is you have to merge it into one file. So we're gonna do it later. All right. So as I mentioned you that since it's stored in DBI file, we have to load the package mean foreign. And also because we are going to conduct tidying the data, we have to also load the package name tidy first. So because it's stored in an RMD file, if you want to run these two lines, you just simply click here, run current chunk, just run. All right. So this is just the warning, but it's okay. All right. After running the package, so you have to read the data. So the first one is we want to read the first file of PODES. Here we use function read dbf, and here is the name of the file. Over here you have the name of the file, PODES 2020 b1 b7.dbf. And then you store it in our data frame called PODES1. Okay, if you run this line, so the shortcut to run a certain file in a certain chunk, you just have to click city control plus enter. So it's just the shortcut. Control plus enter, it means that you only run the row 25. Here in this panel B, you already have that data frame called PODES1. Okay, if you click on this data frame, so you open the data frame PODES1. Here, the data. Okay. Okay. So move on to the next line. Glimpse function is just make it possible to see every column in a data frame. So just want to show you, for example, like this one. It's just like a provide all the column names in here. Just one it's usually used to just check whether you already have the right data or not by checking the column. Okay, in here you can see a bracket FCT. It means factor. It means factor. It gives you an idea where the form of the data, whether it's categorical or non-categorical. Factor mean for non-categorical data. Oh, sorry, non-numeric data. It's categorical. So factor it's for categorical data or non-numeric data. Here we have integer, and then int mean integer, and also I think we have like this one, DBL mean double. It's for it's for numeric data that have a comma. Comma is like not an integer data, but basically integer and DBL refer to numeric data, while factor refers to non-numeric data or its categorical data. All right. So move on to the second files of the PODES. We already load the data in our data frame. So since we have two different files, so we also have to load the second file. So here the 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 syntax, or yeah, the syntax, it's just the same, but we use the different name of our data frame. This is just the name of the file for this 2020 B8 until B13. Just load it, control enter. Okay, see in the panel over here, you should see data frame name PODES2. If you click on it, okay, you find the data frame on PODES2. All right. Is everyone successful to load the data of PODES1 and PODES2? All right. All right, move on to the next step. After loading the data, we have to selecting and filtering the observation and the variable. All right, starting from for this one data frame. Since I already mentioned you that in this case, we only use the data of Central Java province, which the code for R101 is 33 here, 33. Okay. So the first thing first, you have to call the data frame. Call the data frame in, we have here for this one, call the data frame. After call the data frame, you have to pipe it in the text function. Next, the next function, if we use to pipe, and then after pipe, we want to filter row for R01 equals 33. It means Central Java Province. After filtering, since we have to conduct also selecting the variable that we're gonna use in this project, so you have to pipe it again to select function, and then here is just the list of the variables that you will use. All right, run this chunk. Okay. So here you can see in the panel that for this one, previously we've got around 84,000 observation. Now, since we are filtering the province for only Central Java province, now we already have only 8,000 observation. And also the variables, since we select only the desired variables, and the number of the variable also reduced in the new data frame. All right, so next we conduct selecting and filtering as well to the PODES2 files. More or less the same, the syntax. You just click here to run the chunk. So here, over here, you can see that the number of the observation and the number of variables are reduced in the new data frame. So it means we successfully select and filter the observation and the variables that we want to use in the pre-processing data. Okay. So next step that we have to think about is we have two different separate files. It's quite challenging, I think, that if you want to explore the files, but they don't store in the same file. So what we have to do is just to merge PODES1 and PODES2 into one files. If you open the PODES1 here, you can see the information included in PODES1. So in R, to conduct such thing or to merge two files, we have to one identifier for R to be able to match its observation. Here, if you can see, basically they already have the identifier, but they don't unique. For example, here R101, it's only about provincial level. It's not unique. It's the same as what R102. It's about district information. It's also not unique. R103 is for district information, is also ununique, and also this one R104 is for villages. Villages information is also not unique. So what we're gonna do here is to create an identifier that is unique in order to R to be able to merge the data, the PODES1 and PODES2 data. So here we create, here we use mutate. Mutate means we are creating new variable here in PODES1. You have to call the data frame PODES1 and then mutate, creating new variable named ID desa. ID desa is just the combination of R101 until R104. It means that provincial until village level. And also ID, second variable is ID catch. It's combined information of provincial code until sub-district code. And then ID cap means combined provincial code until district code. And then here, if you run this line, Control Enter. If you open the data frame of PODES1, you will have a new variables, not new, you have 3 new variables called this one, ID desa, ID catch, and ID cap. All right. So here, if you print it to your this one, you just basically you just combine R101, R102, 103, 104 into ID desa villages. So it's gonna be a unique identifier for each observation. All right. We do the same to the second file, PODES2, in which we create the ID desa as an identifier to merge them. And also, since both in a file PODES1 and PODES2, we have a column, or we have information about R101 until R105, we deselect this for variable into the new data frame. So here, just run the first syntax, Control Enter. Here on PODES, if you wanted to check PODES2, here you already have ID desa here as an identifier. Since we want to deselect, we want to merge the 2 files. However, the 2 files contain the same information, particularly on this one, R101 until R105. So here in this line, basically we deselect the 4 variables to be not included in the PODES2 data frame. So just run this line, Control Enter. Okay, if you check in the data frame of PODES2, so you no longer find the information of R01, 101 until R104. It already disappeared. All right. So if you, next step, if you already make sure that the both file have the identifier, so the next step, you just simply join or merge the 2 data files. So here we use function left join. Left join means you can like imagine that left join means you have the main data file, call it PODES1, and PODES2. Left join means you want to merge PODES2 into the data frame of PODES1. Just like that, left join. And then join PODES1, PODES2 by, this is the identifier by ID desa, the identifier that are used to join the 2 file into 1 file atau into a 1 data frame named PODES. Just run this chunk. Okay, so in this panel, you can see that you have new data frame called PODES. It has to have the same number of observation as PODES1 and PODES2, right? You see that? Yeah, this is the same number, and because we merge, basically we merge the two files. So, and then the variables, we find more variables in PODES data frame because it's combine the variables that are available in PODES1 and PODES2. All right, up until now, just want to check, is everyone already success to merge the data of PODES? Mm, I get no response. I'm questioning whether everyone are following me or not. I just want to check it. Please give your response in on the chat box, please. Okay, thank you.
I think we have good participants from Lao, very active.
Yeah.
Hopefully others also can give some reaction, so we know whether you can follow it or no.
Okay, I assume everyone already successful to load the data and then to merge the PODES 1 and PODES 2 until make a one data frame named PODES. All right. Okay, move on to generating auxiliary variable. Since we already create a new data frame that is suitable for we to continue to the next exploration, the data exploration. So we move on to create auxiliary variables. First, here I'm gonna back to the PPT file. Let me check first. Okay. Okay. So basically, the project that we're gonna do for data processing is preparing the auxiliary variables in the project named poverty rate, estimating poverty rate at sub-district level in the Java Island using small area estimation. So here we have to generate auxiliary variables from PODES. And I already mentioned that the unit of observation of PODES are villages. But here we want to have auxiliary variables at sub-district level, since we want to estimate the poverty rate at sub-district level. Okay, I hope you can imagine the data frame. We have unit of observation of villages from PODES, but at the same time, we want to generate auxiliary variable at sub-district level to estimate the poverty at sub-district level. So move on to the first auxiliary variable. The first auxiliary variable, this is just the code of auxiliary variable. We call it Sani layak. It's in bahasa. So this is the definition. This auxiliary variable means is defined as villages where the majority of family have access to proper sanitation. Village where the majority of families have access to proper sanitation. Basically, the auxiliary variable tell us about the information about sanitation, and it comes from the data, the PODES data from from 507 A and B. The question 507 A and B. Okay. So this auxiliary variable meaning that the ratio of village with proper sanitation at each sub-district level. How to count it? We count this auxiliary variable by dividing the number of villages where the majority of families have access to proper sanitation divided by the total number of villages. So from this definition, the first step that we need to do is to identify each villages, whether they are classified into whether the majority of families living there have proper sanitation or not. So here is just the definition of proper sanitation. Proper sanitation is defined if the questionnaire or the question of 507A here in the question, code 1, 2, and also have met the condition for question 507B, code 1 and 3. So I'm going to repeat it again. So the village is classified into have proper sanitation if it means the condition of question 507A, code 1 or 2, and also it has to meet the condition of question 507B, has to be 1 or 3. That's the two conditions that a village has to meet to be able to be classified as having proper sanitation. So how you interpret these two conditions into syntax or into code? Let me move to the R. Okay. Right here. So I already mentioned you that first thing first, we have to identify at village level whether a village has proper sanitation or not. So you can imagine that using a code, like if a village have if a village has proper sanitation, we give it a code 1. If it's not, we give it a code 0. Okay, so here is the syntax. Remember that we have two conditions. Okay, we have to call the PODES data frame and then pipe it. You want to create new variable about sanitation. This is just the name of the variable. Okay, and this is the code, the interpretation of the two conditions that we have to meet. The first one is if question 507A equals 1 and 507B equals 1, we classify the village into code 1. It means that the village has proper sanitation. This is also the case for the next slide. If question 507A equals 1 and 507B equals 3, We also classify the village into having proper sanitation, and we give it a code 1. So here also the case. So basically we have, since we have 4 combination, because there are 2 possibility in the first condition and 2 possibilities in the second condition. Here we have to elaborate, or we give it the R, or with 4 combinations of the 2 conditions. And then here we give it 1, and then the condition that don't satisfy 4 combination that we already determined will be classified as 0. Here, you give it 0. All right. If you run this code, Control Enter. Okay. And then you open the PODES data frame. Okay. You go back at the end of the. All right. Here you can find a new variable called Sanilaya. This is the new variable that we all just generated. So it's gonna be dichotomous variable with the value of 1 and 0. All right. So this one meaning that this village is having proper sanitation, while if the variable has 0 value, it means that this village doesn't have proper sanitation. All right. I hope you are successful to generate the new variable. Okay. All right. So move on to the next line of the code. I just want to give you a rule of thumb or something like that, to be able to conduct certain function or certain tasks, you don't necessarily have to stick to one command or one code. There are so many ways to conduct the same work or the same function. Here, for example, I give you an alternative way to generate a Sanilaya variable. For example, this one. Here I create new variable in PODES data frame. Instead of using a function case 1, here I use function if else over here. I use function if else. All right. Remember that we have 2 conditions that we need to meet to classify a village whether they have a proper sanitation or not. Okay. So here we also have 4 combinations of those 2 conditions. For example, first condition is 507A equals 1 and 507B equals 1. This is just the same as this line. And then this is the second combination, is the third combination, this is the fourth combination. So the difference is just in over here. If you use if else, it means that you just put all the combinations of the condition that you need to meet. And then the first value over here is for R, is instruction to R if certain villages meet all the combination, you just have to give 1 value. If it's not, give 0 value. Just like that. It's simple. If you try to run this code, Control Enter, and then open the ODS file over here, you will get the same value, of course, since you use the same condition, right? So this is just give you an idea that to conduct a certain work or certain function, you don't need necessarily like stick to one function. You can freely or find a new function that works to you. All right. Since here in PODES, in PODES data frame, we already identify each village, whether they have proper sanitation or not. So remember that what we are gonna do, or the final result is we want to generate auxiliary variable at sub-district level. So here we still, the information in PODES data frame is still at village level. So you can imagine that to move at like upper level of administrative area, so we have to aggregate all the information from village level to be able to be presented in the sub-district level. So the next syntax or the next code is to create the auxiliary variable at sub-district level. So here we create new data frame. We have to create new data frame because the data is different, because PODES is presented in the village level. So the new the new data file is presented at sub-district level. So we have to create new data frame. Here in this case, we create PODES sub-district data frame. And then what we are going to do is to call the PODES data frame and then pipe it. And then we use function group by. Group by mean we want to group all the observation by certain variable. In this case, we want to group by ID catch. ID catch mean refers to ID for sub-district level. Remember here that in this line we create over here ID catch. ID catch is sub-district level ID. It combine in the combination. It's the combination of R101 until R103. Okay, R1 province, districts, and sub-districts. So ID catch refers to sub-districts ID. Okay, so you have to group by ID catch or sub-district ID. And then after, you can imagine that you have all the observation, and then you want to, this observation are clustered into the same sub-district level. Okay, after cluster all the observation based on the ID sub-district level, what you want to do is you just generate a new variable called this one. What you want to do is to sum all the information of each villages, whether they have proper sanitation or not, or it refers to 1 and 0 value, and then divide it into the number of the village. I hope you understand what I mean. So after you have all the observation of villages, and then you want to R to cluster all the observation based on the sub-district. So the observation in the same sub-district will be on the same group. And then after that, in each group, we want to count the ratio of village that have proper sanitation. To be able to get the value of the ratio, we use the function of this. So R to have to sum the variable that we generate over here, sum this variable, and then divide it into the number of the villages at sub-district level. All right, if you run this code, control enter, and then you will see a new data frame name for the sub-district. You just click on this panel over here, and you see that over here, the observation are reduced over here in new data frame. Since we generate the indicator at sub-district level, certainly, definitely the number of the observation decrease into 500, around 500 observation. So here you can see at the new data frame, the auxiliary variable that we generate is already presented by sub-district level, no longer in village level over here. So what it means with the number is, this is just the number of the ratio of village with proper sanitation. If the value is 1, it means that all villages in the sub-district level has proper sanitation. Whereas if the value is 0, it means that all the villages in the sub-district level don't have proper sanitation. All right. So this line of syntax of alternative way, it just give you an idea, the same as at the previous I mentioned you that to come or to obtain, to generate certain work, you don't necessarily have to stick to one function. In this case, if you want to generate Sanilaya, you can also use the function of mean. Here, mean. It's just the same with this function, but this function is mathematically mathematically we calculate mean by divided the summation of something by the number of something. So here, to shortcut the function, instead of using sum and divided by the number, here we have function of mean. And you will get the same result with this line. For example, here, I'm gonna run control enter, and then this one is data frame of this one. We will get the same number. All right. Next function is just the left join the data into one data frame. Sorry, this is just double. Wait for it. Okay. All right, everyone. Just want to check whether everyone is already successful to generate the first auxiliary variable at subdistrict level. Please, I'm waiting for your response. And don't be hesitate to ask me something that if you cannot follow a certain function or certain part of the code.
Anyone please provide your response? Or if you have a question, you can write it through chat box. I see none. Can we see if anyone can make it? Get the same result with our instructor. No response, meaning everyone successfully execute the command. Thank you, follow PDR again. So any more participants who would like to respond before we continue to the next auxiliary variables? Thank you from Vietnam. Also from Myanmar. Oh, yeah, there is a question on the chat box. Can you explain value 0 and 1 in the file for the subdistrict? Yeah, please, Mbak Erna, maybe you can respond this first.
Okay. Thank you, Miss Tang. The value of 0 and 1 in the for the subdistrict over here, yeah, it refers to this one over here. So if I go back to the PPT file, I go back, check over here. So here we want to generate the auxiliary variable for proper sanitation and to identify each village whether they have proper sanitation or not. We use the value of 1 and 0. So 1 mean we give 1 to the village that have proper sanitation, and we give 0 to the villages that they don't have proper sanitation. How to decide whether they have proper sanitation or not? By these two conditions. These two conditions are coming from the questions of the questionnaire. Uh, it says that if question 507A, one or 2, and 507B1 or 3, we classify the village with having proper sanitation. Just give you an idea. This question of 507A, it's about, the question is about whether the majority of families living in the village having their own toilet, or they don't have their own toilet, or which refer to they use a toilet together with other families. Okay. So here, code 1 means the majority of the family living in the village having their own toilet. And the second options is refers to the majority of the family living in the village use the toilet that are used together with other families. But not everyone use the toilet. It's just designated for certain families, more than one families. It's different from option 3. Here, option 3 refers to the toilet, the public toilet. Everyone can use it. So if the majority of the families in the village use public toilet, refers to code 3, we cannot classify the village as having proper sanitation, because the first condition are not met. Okay. Whereas if the answer for 507(1) or 2, it means that the majority of the village have the majority of families have their own toilets, or either they have a toilet that are used by some families but not public toilet. We can classify it as having proper sanitation. Okay, so we interpret these two conditions into R to be able to execute what the condition that we determined to classify of villages. For example, here over here in our script, we have to write down first the conditions, because we have two conditions and each condition has two options. So here we're gonna have 4 combinations of two conditions over here. For line, it means that if these conditions are met, we want to give it a village that meet the condition with one value. It means that they have proper sanitation. Whereas if the condition are not met, so R will give a village with the 0. Okay, so over here, so by the code, so we will have 101010 at the village level. Okay, so in the file of sub-district over here, it's just the next step that we have to conduct, since the first step that we did is just to identify a village whether they have proper sanitation or not. So we have to create new data frame, because we want to generate auxiliary variable at sub-district level. So we create new data frame called Pode sub-district, in which we aggregate or we average the village based on the sub-district. I mean that here we group by all the observation by sub-district code. So the observation with the same sub-district in the same sub-district will be clustered into one, and then each cluster will be calculated. The mean of the village that has proper sanitation. So if you run this code, mean that this one. So here is sub-district code. It's just the average or the mean of the number of village with proper sanitations. Here, 36 means 36% of the village of this in this sub-district have their own proper sanitation. But over here, in line 5, we have the value of 1, meaning that all the villages in this sub-district have their own proper sanitations. And it's also the case if you get the 0 value, I'm not sure whether we have 0 value. If this value give you a 0 value, meaning that this sub-district don't have a village with proper sanitation. I mean that all the villages in this sub-district have improper sanitation. I hope that it can answer the question from Ms. Tang from Vietnam. Okay. Oh, there is another question. Sani layak not found. It means that you have to run the code again. There's one. If not found, it means that you haven't run the script to generate the certain variable. So you need to do is just to run again the how do you call it, Sunny like dua, yeah. You have to run again to generate the line or the script that related to this code, to generate this code. I hope it works. Like for example, if you cannot find not found Sunny like dua, it means that you have to run again this line, yeah. And then run again all. All right. I hope it works on you and you can solve the problem. Okay, probably Mbak Hani or Mbak Wada, I propose probably 5-minute breaks.
Yes, Mbak Erna, we can have a break now.
Okay.
And we can go back at 10:46.
Yeah. Okay, everyone.
While we have a break, maybe participant can try again the code here and can write if you are facing an issues, can write it on chat box. Miss Erna will respond after a break. Thank you. All right, back again to the session. Is everyone ready to continue the session today? Or any of you still trying to digest the code, the comment that just explained by Miss Erna? Please, before we continue, if you have question, you're facing an issue, please raise your hand. You can speak here or you can write it through chat box. Is everyone's here already or still grabbing a coffee or go to the restroom? Thank you, Miss Yang Tai. Any questions? Or everyone's ready to continue the session? Thank you for the response. I got 3 response only, so any more? Is everyone here? Yeah, our colleague from Myanmar are also ready to continue the session. All right, let us check with Miss Erna if Miss Erna also ready to continue the session.
Yeah, Mbak Ani.
All right, screen is yours, Miss Erna.
Right, everyone, let's continue. I hope you still have many energy to follow me. I hope so. All right, let's continue. Let me share the, okay. All right. Sorry. All right, move on to the second auxiliary variables. Okay, the second variable is about proper drinking water. So here we have the auxiliary variable code of air layak. It's in Bahasa. It refers to a village to identify a village whether it has proper drinking water or not. So it's quite similar with the previous auxiliary variable. So, but it has different conditions. So here, okay, the auxiliary variable are coming from the question 508 and 509, and it also has two conditions. This one, it has two conditions. A village is classified into having proper drinking water if the question 508 having a code for 3, 4, 5, 9, or this one is or question 508 having a code 1, 2, and question 509 having a code 1, 2, 3, 7. So it has this one, it has these conditions. So moving to R, all right. Let me check here, over here. So here, we want to generate the proper drinking water. We assign the variable name air layak over here, air layak. And then based on the condition that I already mentioned in the PPT file, we interpret the conditions into our function over here. If 5083459, we give it a village with code 1. Okay. All right. And the next condition is if 508 is code 1 and 2, 509, it has to be condition 5. The value of 509, it has to be 1, 2, 3, and 7. And we give it we classify a village with a proper drinking water. If all the combination of these conditions are not met, we give it the code with 0. It's quite similar with the previous auxiliary. All right, so this is run this line. And then if you open the PODES data frame, now you can have new variable named air layak. Okay, the value are 0 and 1. Okay, so 0 meaning that the majority of population in this village don't have proper drinking water. While value of 1 refers to the condition in which the majority of population in a village have proper drinking water. All right. Going back to the line. All right. So next step is to aggregate or to generate the information about drinking water into sub-district level. Over here, okay, we create a new data frame for the new information at sub-district level. Here we call PODES data frame, and then we want to group by the unit of observation using ID catch referring to sub-district level, and then we pipe it into how to count or how to aggregate drinking water into sub-district level. Here we use the same function as the previous, in which we divided the number, we sum the number of village having proper sanitation by the number of villages at a certain sub-district level. So here it means that we generate the auxiliary variable of the ratio of village which have proper sanitation, proper drinking water at a sub-district level. Just the same if you run this line. All right. This one you create air layak. If you open the air layak data frame here, this is the result of the ratio of village with proper drinking water over here. So the value, the interpretation of the value is quite similar with the previous auxiliary variable. For example, 0 meaning that all the village at this sub-district don't have proper drinking water. You can see here 0.47 meaning that around 47% of villages in this sub-district have have proper drinking water. All right. Okay, so move on to the next line. So this line basically just to join or just to merge all the auxiliary variable in one file. So if you run this line, Control Enter, and you open the file of what the sub-district, so you can see now a new variable in this file. This is the variable that we just generate about proper drinking water. Okay. I hope everyone don't find any issue to run the code to generate the second auxiliary variable. So we move to the third auxiliary variable. This is just the code. Sorry. Okay, this is just the code of auxiliary variable. This one, basically, it's for it presents the number of families living in slum areas. It comes from the question 512B3. It means that 512B3. So it's coming from this box. So the information coming from this box. So this box is basically contains the information of the number of families living in slum areas. Right? The number of families living in slum areas in each village. All right, so how to generate the auxiliary variable about slum area in district level? So going back to R. Okay. All right. Okay, remember we have to generate, we have to create new variable first at the sub-district, at the village level. Here, we generate new variable called num slum. It equals to the information that contained in 512B3. Since the 512B3 representing the number of families living in slum area. So this new variable is just the same, the equals number of the information contained in 512B3. And then if you run this code and then going to PODAS data frame, you can see here, sorry, this one. You have new variable here. So I cannot find any row that contains non-zero number. So 0 means that in this village, there is no families living in slum areas. This one, for example, it says 215, meaning that 215 families in this village, in this rural village, living in slum areas. All right, going back. If you already identify the number of families living in slum area in each villages, what you need to do is to aggregate the number of families at living in slum area to the sub-district level. Here is the code. It's quite similar. Okay, group by sub-district ID, and then you create new variable over here by summation of the new variable that we already create, the number of families living in slum. This is just the summation. If you run the code and then open up the data frame over here. So here already presented at sub-district level, meaning that over here in the sub-district 33140, it has 200 families living in slum area. It's 0, meaning that this sub-district level doesn't have families living in slum areas. Okay, moving on to this next code. So this line basically want to merge or joining the new auxiliary variable that just we create into the data frame, in the one data frame. So if you run this code and then open up this data frame for the sub-district, over here, you have to see new auxiliary variable that we just created over here. All right. So moving on to the next auxiliary variable, it's related to the education. It's about the educational facilities regarding the availability of school. Here, the first, the auxiliary variable, this SMA, refers to average distance from the village to the nearest high school. Okay, so it refers to the distance. All right, it comes from question 601 HIJ. So I'm gonna give you the example over here. The detailed information or the HIG over here, it's about senior high school. Senior high school level. For example, H is for senior high school, and then I is for Islamic senior high school. MA refers to Islamic senior high school, and then SMK refers to vocational high school. So basically, we want to combine the three specific senior high school level into only one. So we just like make an auxiliary variable regarding senior high school, only one auxiliary variable, which is the average distance. So in the column 4, okay, information in the column 4 regarding the distance of each village to the nearest senior high school. Okay, to the nearest senior high school. So meanwhile, this auxiliary variable is the same as this one, but this one is the average distance of the village to the nearest academy or university. This one is about senior high school. This one is about academy or university. So we create this auxiliary variable. We assume that if a village, are closer to educational facility, we assume that they have higher educational attainment, in which the probability of they are being poverty is also lower. So that's why we include this auxiliary variable that can be presented or that can reflect the education attainment of a certain population. Okay, so move on to the R. Okay, over here. So here we generate new variable called distance of senior high school, Islamic high school, and vocational high school. So here because here we want to get the minimum value of the distance from village. So we use function fp min. So we are finding the minimum value of the distance from the village either to senior, to Islamic high school, or vocational high school. For example, if a village, so the distance of a village to senior high school is 5. The distance to Islamic high school is 2. The distance to vocational high school is 1 kilometer. So this function will give you the number of 1 because it's the nearest, or it's the smallest distance of the village to the senior high school, regardless of what kind of senior high school it is. It could be public senior high school, it could be Islamic, it could be vocational high school. So we are trying to get the minimum value of the distance to the senior high school. So meanwhile, for this line is to calculate the minimum value, or to get the minimum value of the nearest distance of village to the university. Since in the questionnaire we only have one line, go back over here, this one. Academy or university, it's only presented in one category, so we don't need to find using the P function over here, this one. So we define the distance of academy equals to the number that available in this variable. So if you run this, okay, so you will get the two new variables. For here, all right? So meaning that this one, the nearest distance of this village to the closest senior high school, regardless the type of senior high schools are, is 5 kilometers. Over here is meaning that the closest distance of this village to the nearest academy or university is 15 kilometers. All right. So after that, after we're having each value for each village for senior high school and academy information, we aggregate the information into sub-district level. Over here, you can see that. Okay, what makes it different from the previous syntax? Over here, we aggregate only one variable. In here, you can do aggregate 2 variable, 3 variable, or more variable in one function. For example, over here, you call the PODES data frame and then group it by sub-district level, and then you are trying to generate new auxiliary variable, course distance senior high school and distance university, okay, by mean or taking the average of the distance from all villages in certain sub-districts. All right, so this is also the same. You are trying or you're calculating the new variable of average distance of the university by taking average of all distances, the nearest distances from all villages to the nearest university in a sub-district level. So if you run this code and then you open up the data frame, you will get two new auxiliaries variable presented in each sub-district level. Over here, this value representing, for example, over here, it means that the average distance of all villages from a senior high school, from the nearest senior high school to the village at sub-district level is 7.51 kilometers. This is also the same case as this auxiliary variable. Okay, again, here we are trying to merge or to present the auxiliary variable in one data frame. Okay, over here. So up until now, you already count or you already generate 6 new auxiliary variables. All right. So this is also the same as this is the next auxiliary variable. It's related to the health facilities. So in PODES, we elaborate. Okay, let me move to the PPT file. Okay, so over here, the next auxiliary variable is related to the health facilities, in which PODES elaborate different kind of health facilities. For example, here in A, we have hospital, B, we have birth hospital, and then in C, we have like a clinic, and then something like that. It's different kinds of health facilities. So what we're gonna do is quite the same as the previous variable. We want to find the minimum distance of the village to certain health facilities. Okay, the logic is the same as the previous auxiliary variable. Okay, try to run this chunk. Okay, all right. If you check the data frame for the subdistrict over here, you will get new auxiliary variable about health facilities. All right. Okay. All right. So basically, you you can do you can do generating all the variable in one function instead of one by one. For example, here, I just want to give you an idea that we can generate all the auxiliary variable in one function. For example, over here, after you are, of course, at the beginning, before you pre-processing the data, you already have a list of auxiliary variable that you want to generate first. Probably you determine it from having a reference or something like that. And then after you determine the list of auxiliary variable, and then you move to R and then trying to generate all the auxiliary variables using one function is over here. I'll give you an example. Yeah, you're trying to generate this one, this auxiliary variable over here. This one we are trying to generate five auxiliary variable at village level. Remember that? This one is also at village level. So here we are trying to generate 10 auxiliary variables using PODES. If you run this chunk, okay, and open up the data frame here. You will have 10 auxiliary variables. Okay, after that, after identify or create new auxiliary variable at village level, what we want to do is getting the auxiliary variable at sub-district level. So over here, so also, and also you can do it in one function as well. For example, for here, okay. Okay, I still use the name of the variable for this sketch. Okay, trying to enter it. Control enter. Okay. All right. So this is the result of 10 auxiliary variable that already presented at the sub-district level over here. All right. Okay. So we are done. So we already get 10 auxiliary variable from PODES. And then I hope everyone can follow me, and the syntax or the code also doesn't give you an error or something. Okay, for example, so in this case, to estimate poverty, other than using data from PODES, we also use the data from a satellite imagery called NTL. NTL refers to nighttime light. NTL, nighttime light. So here, I already give you the data. It's on a CSV file. Okay. If you reading the data, this slide. Okay, NTL. All right. So over here, basically, you also have an ID for each sub-district. You already have ID for each sub-district. Okay. And then since the data of NTL also covers all the region beyond Central Java province, here we are trying to filtering only the NTL data for Central Java province. If you run this line, Control Enter. So in NTL, in a data frame NTL right now, you only have the data from Central Java province. And then after that, okay. All right. Okay. So NTL claims. Sorry. Okay. So since the ID over here, let me see. Oh yeah, okay. So if you see this by using the function glimpse, the ID catch variable is still on the character. It's mean non-numeric variable. So if you want to merge the files, the identifier has to be in the numeric variable. So in this function, I try to change this identifier into integer as a numeric number. Okay. Successful. And then here you are trying to merge the NTL data into the NTL data into the, sorry, I have to change this. Into the data frame that contains all auxiliary variables coming from PODES. Okay, if you run this code, due to incompatibility types ID underscore, okay, I have to run this code. Okay, not showing. ID catch. Oh, I see. Sorry. Let me check it. Okay. Okay. Okay, you see that the identifier has to be the same type, in which has to be the numeric variable. You have to make sure it. If it's still in the character format, you have to change it. And then after that, you join, and then we have new data frame called auxiliary aux. So here, see, okay, You already have NTL data in our data frame that combine all the auxiliary variable coming from PODES and NTL data. Okay, and also after you have all the lists of auxiliary variable in one data frame, you can also create the CSV file or the XLS file that contain all your new auxiliary variable. For example, here in this line, you want to store your auxiliary variable in CSV file, and then here you can use this line, just run. And if you can see here in your R project, you can find the wait. This over here, PODES Central Java District in a CSV file. So whenever you want to do something in all the auxiliary variable, for example, you want to start modeling the psi modeling, you just simply go to this file, and you don't necessarily have to run all the auxiliary variable from the beginning. So it's shortcut. So it's, yeah, so it creates new data set of CSV or in the format that whatever you want. All right. That's all. I think that's the steps that you need to do to generate the auxiliary variables, and probably the data sources or the senses that you use might be different from that I use right now, PODES in this case, but basically the function or the function or the type differs. At least you can copy it, or you can like adopt it that from the syntax or from the code that I use right now. And then the last one is, after having all auxiliary variable, we normally conduct ADA, exploration data analysis, in which we are trying to have a look at the probably distributions or the distribution or the correlation of our auxiliary variables in terms of how in terms of we determine which auxiliary variables that we want to include or that we want to exclude to our psi modeling. So normally we do it based on the exploration data analysis. For example, here, this line is trying to give you the graph. If you run this code, all right, it will give you the scatter plot over here. All right, this represent district. This is represent this is for the data of clean water, clean drinking water. I think that's the clean drinking water. This is for sub-districts. Sorry, I did some mistake. This is actually for sub-districts. So this is the number of that representing the ratio of villages at sub-district with which have proper drinking water. So if you see this graph, I would prefer, I tend to conclude that this data, we can use it in psi modeling because the level of homogeneity is quite good. It's heterogeneous. So it could be very potential to explain or to be our auxiliary variable to estimate our poverty. Meanwhile, if the scatter plot show us the homogeneity, for example, all the value are centered in 0 or 1 number. So I might not use the auxiliary variables because it's very homogeneous. All right, this is just one example. And then another graph that you can use is, all right, this one. Sorry, I cannot zoom in. Zoom. Okay, this one. This one is give you the histogram to see the distribution of its auxiliary variables. Well, the decision of you use whether you include or exclude the certain auxiliary variable, it depends on your psi modeling. If whether it's the modeling require you to meet the normal distribution, or whether your psi modeling that you use non-parametric, so you don't have to satisfy the normal distribution assumption. So it depends on your psi modeling. So here I just want to emphasize that after you are having auxiliary variables, it's really crucial for you to conduct some exploration data analysis because in many cases, there are many auxiliary variables that it would be better for us to selecting or filtering the most suitable auxiliary variables by doing exploration data analysis. I thought that's the end of my sharing for today. I hope you can follow it, and if I hope also you all successfully run the code. Or if you have any question or inputs or comments, please. Or I give it back to Mbak Wardah.
Thank you, Mbak Emma, for the exercise, long exercise one. Hopefully, all participants can follow the steps. Again, we would like to invite if you have any question to Miss Erna, you can raise your hand, open your camera, and or otherwise you can also write your question in the chat box. So please, everything is clear enough, and you can follow the steps until the end of the sharing. I take silence as a yes, so hopefully, okay, Lao, clear enough. So Miss Anna is successfully explaining in explaining the step then. So everyone is clear
Hopefully, Mbak.
on the process. I know it's already long, but as I mentioned earlier, we need to briefly discuss also on the data preparation. Now, I would like to invite participants, each country. Maybe you can indicate to us what data that you choose to be used for the exercise, with the poverty related one or the employment related one. And if you have already prepare the variables, you may also share to us. Unfortunately, Myanmar mentioned that some are mixed due to connection. That's why we will practice. Okay. So you may get all the documents in the link shared by Hanik through email. And then when you do practice after this session, if you have some questions, you can email to us, ASEAN Secretariat, and we will convey your question to Miss Erna, or you can also directly email to Miss Erna. Okay, anyone else who would like to provide reaction or any issues or challenges that you face during the session? If not, then we go back to question on the data again. Is there any participant from Cambodia here? May I check? Is there any participant from Cambodia, please? Okay, no reaction. So next is Lao. May we check with participant from Lao? Do you have already prepared your data? And what data that you prepare? Can you turn on your camera or turn on your microphone, please? Just briefly mention about the data that you prepare. Or if you haven't prepared any data, you may also speak if you don't, if you would like to get any information on what kind of data that should be prepared. So please, Lau.
Yeah, thank you. Thank you for my. I have prepared data about employment rates and
Mhm,
poverty rates, but
mhm,
uh, administrative in Laos is a province, district, and village. We have only at the province level.
mhm.
District and village we didn't have information.
You don't have you only have the data until province level.
Yes,
Okay, Mbak Erna, what about the situation in Laos? They only have the data until province level.
yes. How can we do with this only?
Is it still possible to use the province level data and then do small estimation for district level?
Maybe I think
Yeah,
I
we would
hope.
like to hear from our expert from Indonesia.
Yes,
Not really expert, Mbak Warda, but
Yeah,
just
of
like
course. Our research person. You have you have
yeah.
more experiences than me.
Yeah, due to we have only the survey data in each province, not all district. We enumerate the information. We don't collect all district information from. We select only some district and some village in each district, and that that's our sample. We don't have the estimate at the village, also province, no, and district. Only province level we have the
Mm,
accurate information.
okay. Any feedback, Mbak Erna?
yeah.
Miss Erna?
Okay, Mr. Song. Okay, so
Mbak Erna, your voice is quite.
okay,
It's like
check.
you walk from far.
Is it clear, Mbak Warda?
Not really. It's
Okay,
Can you
but right now,
increase the volume? Maybe
check.
something not still something error with your microphone. Can you speak closer to the microphone?
Check. Yeah.
No.
Sorry, I think we have to take a break right now. Sorry, Mbak Warda.
Ah,
Check.
okay. Try again.
Check.
Yes. Okay now.
Okay. So okay. Basically, when we are conducting small area estimation, small mean refers to certain area, uh, regardless of which administrative level, in which we cannot get the accurate estimation using the survey or using survey. So here we have to conduct small area estimation. So I think we don't necessarily have to determine the same administrative area in which we have to conduct small area estimation. what I mean is, for this case, in this case, we are trying in Indonesia, we are trying to explore or estimate small area estimation in the sub-district level, since the survey only able to estimate or give the accurate estimate or accurate statistic at a district level. In this case, here that's why we conduct SAI in the sub-district level. In the case of Lao, uh, since the accurate statistics
It's
uh,
province.
are available in province level, so here we can define small
Area
area
estimation for district
as,
one.
yes,
I see.
exactly, yeah.
Okay. So you are safe, Mr. Somsamai. It's okay to use the province level data to estimate the district level data. If you
Yeah.
need further input on your data that prepare, you may also send the list of variables to ASEAN Stats, and then we can convey to our research person from BPS, including Miss Erna, to check whether the variable selected is good enough or need some additional variables. We will try to get feedback from our resource persons. So is it possible for
Yes.
you to send us the data that you already prepared?
Yeah, I will send, but in 2017, because 2022, we have an only small sample on unemployment rate, only 62,000 in
Okay.
whole
It's
country. So
it,
we break down in the province. It cannot. Some province only very
it's
few.
it's okay. You don't need to send the data to us. Just the
Yeah,
list of
yeah,
variables you selected.
yes. A
Okay.
list available.
Okay. So I since this one is for the exercise one, it's not really necessary on the year, but uh, so 2017 data is should be okay. Thank you, Mr. Somsamai from Laos. Can we hear also from Malaysia, please? Anyone from Malaysia would like to speak on data preparation? No respond. Can we move to Myanmar? Can we hear also from Myanmar? What have you prepared any data for the exercise and what kind of data that you choose, whether it's employment or whether it's poverty related data? And any issues or challenges in preparing your data? Can we hear from Myanmar? No response also. How about Vietnam? Can we hear from Vietnam as well? No one. Okay, for Vietnam, have you prepared any data for the exercise? And what kind of data? Employment related or poverty related? What kind of data did you prepare? Poverty or employment data? If we may know, so including variables that you select, so our research person can provide feedback. Or you haven't prepared your data yet? It's okay also. But if you need any guidance to prepare your data, please let us know. Our Miss Erna can briefly provide you information on what kind of data that you should prepare for the exercise. Okay, what about our colleagues from Timor-Leste? Are you interested also to join the exercise using your data? And have you prepare any data for the exercise one? No reaction. Okay. Okay. Since no reaction, wait, for Malaysia, we'll try to get implement data for this training. Okay, thank you for the information from Malaysia. Malaysia will work on the employment data. If you have any issues or if you need input, feedback on what kind of variables that should be included, let us know. And same to other countries also, including those who don't provide any updates to us yet now. First, if you haven't prepared the data yet and you need input on what kind of data that you should prepare, let us know. We can communicate it through email. Second, if you have prepared your data and select some variables and you need inputs, please let us know also. You can send us the list of the variables that you currently already prepare, and then our resource person from Indonesia, Philippines, and Thailand can help provide any feedback whether it should be sufficient already or need additional data. I think that's all that I can say since some countries, no response from some countries. So I think it's enough for today's session. Before we close, I have tried, but my internet connection is open issue, but I will try to communicate with this person on this. Thank you, Mr. Jacob from Timor-Leste. We can communicate through email, including on the data preparation. If you need inputs on the data to be prepared, let us know through email also. I think since yesterday we forgot to take picture, so can I request everyone to open your camera? And then only three of us open the camera yet. Okay.
We can wait a little more.
There's no response yet. Okay. Anyone, could you please turn on your camera? Okay. Hamid, you can just take as it is.
Sure.
I'm
So,
sorry, I forgot to do it in the introduction part.
if anyone want to open the camera, please do so. Well, please be ready. I'm taking the picture now on my count. I have 2 pages here, so I'll take twice. Okay, first take on my count. 1, 2, 3, please smile. Okay, one more. On my count. 1, 2, 3, please give your best smile. Oh, we have more participant opening the camera. I'll take one more. On my count now. 1, 2, 3, please smile. All right. Thank you, everyone.
Thank you everyone, and thank you, special thanks to Miss Erna, who's our resource person for today's session, and to Miss Dewi, our resource person for yesterday's session. And then for those who have any issues, any question, you can email to us. We can communicate it through email. Don't forget, we will have another session next week. We will send you a reminder on Monday because the session will be on Tuesday,
Tuesday, 29.
29 of October, 29 and 30 of October. So hopefully for those who have not prepared any data yet, today, next week, you already have some data, and if you have any issue, you can also inform us. So thank you to BPS colleagues. Thank you to all participants. Any question after this, you can send to us through email, and have a nice
Thank
lunch.
you.
Bye-bye.
Thank you,
Bye-bye.
everyone.
thật là cái lừa